Hello. Today I'm gonna talk about conservation, but planning, how to create the corridors, um, network, corridor network by values. So basically, it's a network analysis. But just some algorithms down here. There's a really handy tool called CAT, Connectivity Analysis Toolkit. You can download it online. It's free and but there's some specific steps on this. Okay, there's actually just a series of steps. One is you want to create a hex maps. What they do is they this raster, right? You need a suitability map. So this suitability map is in terms of the most suitable habitat. Okay, the higher value, which means they're suitable for certain habitat for your needs. Okay, um, whatever the need are. So the best place are what the higher value, and then they just need one map, and it's a raster. And what they do is they create a raster in GIS, and they output to use the output to ASCII, I guess. Let me show you. Is ASC file. Okay. So basically, if you search the tool, is you know actually they all works. Especially I think the raster to ASCII. That's what we want. Okay. But the issue is, see here, I open the ASC file. The issue is you don't have a reference, georeference. It's not georeferenced. So once you export that, please remember the coordinates of the edge. Okay, for example, you want to know what's the coordinates of these points, these points, these points, these points. Okay, so we could in the future we could we create our output. We could georeference them back to our map. Okay, so this is the first one, and the second one, sometimes we have another one called cost, which means this is suitable area, and then we need to figure out what's the cost of doing that. Okay, just sometimes we have two variables, right? The suitability and the cost. Okay, we want to have most suitable places with least cost, those kind of things. Okay, um, for the first thing, if we want to do, if we try to do in terms of connectivity, and there's graph. So this is just some like files to put in there to help them analyze the connectivity. And the connectivity is the main one is they have a lot of math source functions. Actually, what we do is what we use as tree. One the shortest path, current flow, and minimum cost flow. Okay. Um, in this case, we will do minimum cost flow first. Okay, that's I think the most used one. Okay, it's pretty good. Um, it's close to least cost, but they just have a minimum cost down there. Okay, this is shortest path. Okay, okay, good. So and the first step is you wanna use the habitat, use the ASC file as graph source, and you just give them location or output, give a name. I usually name it. Um, and the other important thing is the hexagon area. So the area unit I think is a hectare. So how to you should have a good um, for example, like this is the size of like 4,000 hectares. So you want a hectare like this big, I guess. So it's close to like 200 hectares. Okay, um, or 500. Okay, so in this case, I just use 500 hectares. So you don't want this number to too small or too big. Okay, you have to make them accurate, appropriate. So this is good. Let me just run, and you will get a series of file. Your output. Okay, they're still running. So you will find out they get a series of outputs, and it's all habitat 500. They have a CRD, which is the coordinates. They just give you all the coordinates for the hexagons. And this is a shapefile. You have a shapefile, so basically they're creating a shapefile. Okay, so the size, every size is 500 hectares. Okay, and they have a score. So this score is the value of the suitability map. Okay, you will find out that they are the case. Okay, of that. Okay, it's like zonal statistics. Um, so this is pretty easy. So you do this one, you do the suitability map, and you will do the same thing for the cost. Just make sure you do that, and you name it cost. So you have to just run them. So in the end, you should have cost. So this is the cost, okay, and the number is different. Okay, it's the cost. It's the number of the cost. Okay, so here is all one. So we'll have some zeros. Let me see where's the zero. See here. See here, it changed to negative 9999. Okay. Um, and here, see here, this is 4. Okay, if I just classified my cost layer, so you can see right now, you can see the cost. So here, this is 4. So very different cost. Okay, and it's showing up in this file. But this is just shape file. The most important file is this hxn. So hxn file is the file we really gonna use later. Okay, so what we're gonna use is in the graph, and the hexagon source we want to use this hxn. See here, is in habitat. Okay, that's graph, and the cost we want to use the cost. Okay, the cost 500. So just make sure you use that. And then output file, we can output to, see here, and it's LGF. So this is what they call the graph file. So we just name it. It's like list cost graph file. So let's name it list and max list cost. So that's what we do, right? We want a maximum suitability by the list cost. Okay, LGF. Actually, just name it graph. So click save, and just make sure here it's really important. You want to select undirected because they can go both way. And all other edge list, all those is not for maximum suitability and list cost. Okay, and here convert score to integer. I think we can just make one decimal down there. So yeah, so we have more accuracy and we hit 1. So this is the mean max cost. So let's just run it, and actually it will take some time, and let me just pause. So once this is finished, you will see they create a file. It's max list cost. When you open up, it's just a series of it's like a code, right? All kinds of numbers. They will basically they have coordinates, and they set the scores. Just combine these two into a file that this tool can read in the next connectivity. All right. And then we go to connectivity, and we want to choose minimum cost flow. Okay, and we just find this, LGF, the graph file, and in the input type, that's kind of special. Is to us it's generic. Okay, it's generic data, and because we're using the minimum cost flow. Okay, yes, it's minimum cost flow. So for this one, we need to have specific like destinations. All right, what's the source? What's the target? So we need to browse and find that file. So there's a file in here. You need to prepare a file which is called source target online. I'll show you what that file was. Um, so basically, this file is actually this file. Actually, I need to go to two line. So you need to have two lines in text file, and all those two lines are the number, the ID, what they call hex ID of the shapefile we created. For example, like, so wait a minute, let me see here. So you see here, there's the hex ID, right? So all these numbers are their hex ID. Okay. So basically, they just find out the hex ID targets, and they will connect between those targets. Okay, do connections between those targets. And the interesting thing is you want to make sure is it has to be lines, two lines. Okay, it's one line, and then we have another line. So just make sure it was two lines. Okay, two lines is important. Okay, so this tool can read that. Okay, maximum distance. I don't think we have any requirements on that. Usually all the default are good. All we need to do is just make sure the output is what we want. So we aren't list cost, result. So and give a type which is, let's make them tab. So tab is what the output should be. Okay. Click and run it. Wait a minute. So after couple, several minutes, and we got a file, and you will see this file is we have a hex ID and we have value. Okay, so value basically is the connectivity. Okay, value, which means if value is high, which means there's a higher, this really valuable corridor. It should be in that cell. Okay, so what we need to do is very simple. We just use this file and join this file to this um, hexagon shape file. So the input join field, we want to choose hex ID because here we have the results. We have a hex ID which is the same with this shapefile. And join table, we want to choose to find out where it was. Think somewhere. So it's called tab. So actually, since we are in Pro, so I think in here there's some change, which is the connectivity, right? We wanna change the name of this file. It's tab before, and we want to change to txt because if it's text, I cannot find the text this file in my folder. So just change them back to txt, all right? And then we go back again, join and relate. So import field hex ID, and see here they will automatically detach, find the text file, and just run it. And after a while, you will have a new layer called value, and we can just show that value file. See what it was. See how it looks like. Single value, yeah, value, and let's find the value. And just wait a minute. And the issue is you will find out, see here it's been like 10 minutes, but the issue is this file is so big, it's huge. Okay, since it's really big, so we usually want to export data, export this feature, and just export them uh, to your database or to your folder, to your shapefile. So let's just find the folder I am. So let's name this. Let's name this like min max cost. Save it. Strong. Yeah, we want to export it, so we can open them again and use. So the file is gonna be faster. Okay, showing up faster. But you can see here already. We see this is a target. This is another target that will connect them together. Um, just wait a minute. Okay, we have a new one. So this is min max cost, and let's just go to symbology. We can show in colors. We can choose the field. And for some reason, the field's name just messed. But you could literally change the names. But here the max list one, this is our value. Okay, table. Um, so you just need to spend some time to change the table. See here. So this should be just go to you can change the name, right? So right now I just go to fields and change the field name. Um, Wait a minute, let me see. Okay, there you go. So see here, this change the value, so it becomes normal. Okay, see here, what is this one? So this top one, they have a value, and but see here, this is the top one. Um, Let me see what's the value around it. It's like 400 something, so pretty accurate. Okay, that's what we need. So we have this value is the value in terms of um, if we show up the map, right? If we turn this to transparent, no color, no color apply, and see here they will tell you what's the strength of the connectivity between these 2 points. Okay, all these routes is minimum cost and the maximum suitability, but there are but the higher value, which means they overlap the routes overlap, um, which is pretty cool. Okay, um, so this is just going to give you a great way of thinking about um, how to connect this point to this point, right? Um, so I think that's this. This video is pretty long. I will talk about the other concept later. Thanks.